this video is about rational inequalities. Now, rational inequalities is any inequality that contains a rational expression, for example 2x over x plus 1 minus 2 less than 0. This is a rational expression, and therefore this inequality is called the rational inequality. Now, the way we are going to solve it is to first write it in standard form, meaning that 0 on one side, and then factor the numerators and denominators. So here we will have usually linear factors. Then at the end of the day, it's like analyzing the sign of this expression made up of many factors. These factors here can be, for example, positive, negative, negative, positive, and so on. And then we go and use the rules of signs, multiplication and division. So, for example, minus multiplied by plus gives me minus, negative. Negative by negative gives me positive. Positive by negative gives me negative, and negative positive multiply positive gives me positive. Similar rules when you divide. If you divide a negative number by negative number, you get a positive number. If you divide a positive by negative number, you got a negative number. If you divide a positive number by another positive number, you get a positive number. And the rule, negative over positive gives you a negative number. So we are going to combine these rules, go to this fact, combine these rules, multiplications and divisions, because we have multiplications and divisions as well. Combine them and study the sign of this expression here, because this is what we are looking for. Something else about the rational inequalities is to never multiply or divide by an expression containing x, simply because you don't know the sign of this expression. Remember that in inequalities, when you multiply or divide by negative number, you need to change the symbol of inequality. Let's take an example to be clear about this. So I have got 2x plus 3 over x minus 1 bigger than 2, and I am tempted to simplify this x minus 1, which is in the denominator. So I would say, okay, let's multiply by x minus 1 here and by x minus 1 on this side, and then simplify and get rid of the denominator. You cannot do it here simply because you don't know whether this x minus 1 is positive or negative. But we will see there are methods, of course, to solve these inequalities. Let's look at example number 1. In example number 1, we have an inequality that is already factored, numerator and denominator, and written in standard form with the 0 on the right side. So all what we need to do is to study the sign of x plus 4 of all the three factors. Okay, let's start with x plus 4. X plus 4 is positive. Now, if I solve this inequality, when x is bigger than minus 4. X minus 5 is positive. I solve this linear inequality when x is bigger than 5. And the last one, x plus 3, is positive when x is bigger than minus 3. Now let's make a table of sign and put all this information together. So let's have a table like this. Now we look at the zeros. minus 4 is the 0 of x plus 4, 5 is the 0 of x minus 5, and the minus 3 is the 0 of x plus 3, and then we order them from smallest on the left to the largest on the right. So minus 4 is the smallest, and then minus 3, and then 5. Here large numbers plus infinity, here the smallest numbers minus infinity. So we are going to work on these 3 intervals. Good. Now let's start with the factor x plus 4. Now when we solved x plus 4 bigger than 0, here, we ended up with the following conclusion: when x is bigger than minus 4, this is positive. So this is positive when x is bigger than minus 4. Minus 4 is here, bigger is here, and here, and here, and plus infinity. So we go and we put plus, plus, plus. Of course, less than minus 4, x plus 4 will be negative. When x equal to minus 4 exactly, it will be equal to 0. So we put all the information. Now, let's follow up with x minus 5. Now, x minus 5, here, x minus 5 is positive for when x is bigger than 5. This is 5. X bigger than 5, it's in this direction here. So, this will be positive. X minus 5 will be positive here, will be negative when x is less than 5. Here is 5 less. Let's have a look at x plus 3. Now let's not forget the 0. When x equal to 5, x minus 5 equal to 0. Now x plus 3 is positive when x is bigger than minus 3. Here is minus 3. For values bigger, it's going to be positive here, and then of course here and here negative. Now the 0 of minus 3, I am going to put a cross. Why? Because remember, the x plus 3 is in the denominator. Minus 3 in the denominator will give you 0, and it's not allowed. So I will put a cross here. Now I go and study the whole expression. My whole expression is the one on the left, and I call it y. Y here. So y is equal to what? X plus 4 multiplied by x minus 5 divided by x plus 3. Okay, we start from minus infinity. So from minus infinity to minus 4, x plus 4 is negative. X plus 4 is negative. This is negative. Multiply by x minus 5. X minus 5 is negative. Divided by x plus 3. X plus 3 in this interval is negative. Apply the rules of sign. Positive, negative, negative in the denominator. In the numerator gives me plus, minus, and the whole thing will give me minus. So I go here and I say y is negative on this interval. Be careful. Now we go to this interval, so to minus 3. Okay, the first factor, x plus 4, is positive. So positive. Multiply by x minus 5. X minus 5 here, it's negative. So I put negative. I divide by x plus 3. X plus 3 here is negative. And when I do the rule of sign, I will have negative over negative, and the whole thing will be positive. So I go here and I put positive for y, which is this here. Okay, now we go to the interval minus 3, 2 plus 5, and the same thing. X plus 4, it's positive. So it's positive. multiply by x minus 5. X minus 5 here is negative, and then divide by x plus 3. X plus 3 here, it's positive. Now the rule of signs, minus, plus, and this will be minus. I go here and I put minus. Now we go to the last interval, 5 to plus infinity, values greater than 5, and we do the same thing. X plus 4 here, it's positive. So positive number multiplied by x minus 5. X minus 5 here, it's positive. And then we divide x plus 3. X plus 3 here is positive. This is positive, yeah? And then when we apply the rule of sign, positive over positive, that gives me positive. So I go here and I put positive. Now let's write the solutions. So remember, what we are looking for is y less than or equal to 0. So this expression here, y less than or equal to 0. So where we go, this interval is negative, good, no, good, no. Now we start writing our intervals. This interval where it is negative, we want negative, it's from minus infinity to 4. So let's use the intervals because they are quite easy. Minus infinity is always open, minus 4, let's leave it like this for the time being. Now this is also negative, we want negative, so minus 3 to 5. So minus 3 to 5. Let's see where we're open or close. Now we want less than or equal. So any value that makes the numerator 0 is also accepted. Let's look at minus 4. Minus 4 is the 0 of x plus 4 that makes 0. So minus 4 is accepted. We close the interval. Union. Now minus 3. Minus 3 it's the 0 of the denominator, not included in the solution because it makes the denominator 0. We don't like it. We don't accept it, sorry. Now 5. How about the 5? 5, it makes 0 in the numerator. So we take it because we want the 0. Look, we equal to 0. So we close it. This is the solution in interval form. Now let's use the number line and put all the information we have on the number line. So minus infinity, minus 4 accepted, so close the circle here. So these values are the solutions. And then we go somewhere to negative 3. This is an open here. So an open circle and up to 5 with a closed circle, accepted. So minus 4 and 5 are part of the solution. And let's write it now as using inequality symbol. So less than or equal to minus 4, this side, or x greater than, so this is negative 3. So greater than negative 3 and less than or equal to 5. Equal, closed, open, no equal, closed, equal. So this is the solution in interval form, a graphical form using number line, and the third form is using the symbol of inequalities. Now let's look at example number 2. Now in example number 2, it's not in standard form, so the first step is let's put it in standard form, meaning that the inequality will have 0 on one side. Standard form. So this is very simple to do. X plus 8 over 9 minus x2, and then we subtract 2 from both sides, and that will give me the x plus 8, 9 minus x2 minus x2 minus 2 bigger than or equal to 0. The second step is to start factoring. The second step is common denominator, because this is a rational expression and this is a number, so we need to put everything to the same denominator, which is 9 minus x2, so that will be 2, and I multiply 9 minus x2 top and bottom, bigger than or equal to 0. Now this is a common denominator, so I can group the two terms and write it as follow: x plus 8 minus 2, 9 minus x2, and then here common denominator. Now all this bigger than or equal to 0. Now we expand the numerator: x plus 8 minus 18 plus 2x2, 9 minus x2 bigger than or equal to 0. Group terms in the numerator. We have the 2x2 plus x minus 10 over 9 minus x2 bigger than or equal to 0. So this is in standard form. Now the third step is to factor both numerator and denominator. Okay, so the denominator is very simple. It's the form a2 minus b2. It's the difference of 2 squared, because remember 9 is 3 power 2. So to factor the difference of 2 squared, a2 minus b2, it's a minus b times a plus b. So 9 is 3 power 2. That will give me 3 minus x multiply 3 plus x. Now the numerator, let's put 2x here and x here, and then we need two numbers. When we multiply them, they give minus 10, and then when we add them, they give plus 1. Now let's not forget the 2 here. So it looks like it's either plus 5 minus 2 or 2 minus 5. So yeah, let's check this. 2x by x, that gives me my 2x2, and then I have got 5x and then minus 4x, plus 5x, 5 by x, and then minus 4x, that gives me the 1x, and then 5 by minus 2, that gives me my 10. This is correct factoring. So that's it. So the factoring is done. Now we take each term, each factor, and we analyze its sign. This is going to be positive if solve this linear inequality. Minus 5 over 2. So this is positive when x is bigger than minus 5 over 2. Let's go to the factor x minus 2. X minus 2 is positive when x is bigger than 2, and then we go to this factor and this factor. So 3 minus x bigger than 0. Now when you solve this, you are going to say that x less than 3 here. 3 plus x bigger than 0. We solve and we find that x is bigger than negative 3. So let's put all the information that we have on this table. Now the zeros are minus 5 over 2, 2, 3, and minus 3. The smallest one is negative 3 here. The next minus 5 over 2 here. And then the 2, and then the 3 here. Plus infinity, minus infinity here. Now we create intervals at the zeros. Now we start. Now 2x plus 5 is positive when x is bigger than minus 5 over 2. Minus 5 over 2. Minus 5 over 2 is here. So 2x plus 5 is positive here, here, and here. for all values of x bigger than 5 over minus 5 over 2. Here it will be negative. X minus 2 is positive when x is bigger than 2. 2 is here, bigger than 2 is here. So x minus 2 will be positive here and here for all values of x, bigger in this direction. Now here it will be negative. Now let's not forget to put the zeros. Yeah, 2x plus 5 is 0 here. X minus 2 is 0 here. Now let's go to the terms that makes the denominator. 3 minus x. 3 minus x is positive when x is less than 3. Here is a 3. Less than are these values, so here it will be positive. Here it will be negative. Now this value of x equal 3 makes the denominator 0, so I put a cross. That means this value will not be accepted as a solution. 3 plus x now. 3 plus x is positive when x is bigger than minus 3. Here is minus 3. When it's bigger, when x is bigger, that means to the right, it's positive, and positive. Of course, here is negative. X equal minus 3 makes the denominator 0, so I put a cross. Now, remember, we are solving this inequality here. So let's call this quantity on the left, we call it y, and we put it here. Now let's look at the sign here. 2x plus 5 here, it's negative. Now look at the sign on each interval. So we're looking at the interval minus infinity to minus 3. 2x plus 5 is negative, x minus 2 is negative. When you multiply them, they give you a plus. Denominator, 3 minus x is positive, this one is negative. When you multiply them, they give you minus. So plus here, minus here, that will give me a minus. My y here on this interval is negative. Now we look at the interval minus 3 to minus 5. 2x plus 5 is negative, multiplied by x minus 2 negative, that will give me plus in the numerator. 3 minus x is positive, 3 plus x is positive, positive by positive gives me positive. So positive here, that will be positive when you divide. So we go here and we put the plus. Let's go now the interval minus 5 over 2 to 2. So in the interval minus 5 over 2 to 2, we have 2x plus 5, it's positive. So 2x plus 5 is positive. 2x plus 5 is positive, and x minus 2 is negative. So that will give me I will now go to the interval minus 5 over 2 to 2. 2x plus 5 is positive, x minus 2 is negative. When I multiply them, they give me a negative number, a bar in the numerator. 3 minus x is positive, 3 plus x is positive. When I multiply them, they will give me a plus here. So minus, negative and positive divided will give me negative. So all y will be negative. Here everything is positive, so we would expect the y to be positive. And here it will be positive for 2x plus 5, positive here. So positive in the numerator, and then negative in the denominator, and then positive by negative. This will be negative. So this is the solution using intervals, number line, and the other forms, of course, will follow. So we have minus infinity, plus infinity, minus 3 somewhere here. We open the circle because of the open interval. Now minus 5 over 2 somewhere here, and of course closed circle because it's accepted, and all the values between negative 3 and negative 5 over 2. Now 2 accepted, closed, 3 open, and we take the values here. Now we are going to look at the third form, which is using the inequalities. Bigger than minus 3, strictly, less than or equal 5 over 2 minus, or x greater than or equal to 2, less than 3. So interval form, graphical form using the number line, and the third form using the symbol of inequality. Now let's look at example number 3. So it's already written in standard form. We have a 0 on one side. It's not factored. The numerator, it looks like complicated. So let's start working on the numerator. Okay, so x plus 3 in the denominator. Now the numerator, we have got 1 plus a rational fraction. So let's rewrite the 1 as 1 times x plus 1 divided by x plus 1. What I'm doing here, I am rewriting the two terms in the numerator to the same denominator so that I can go and just add them together. So in the numerator, I have got two rational expressions. When I add them, the denominator is common. The numerator x plus 1 plus 1, that gives me x plus 2. The denominator is x plus 3, bigger than or equal to 0. Now, before we go any further, let's look at any value of x that will not be accepted as a solution. So for example, we have x plus 1 in a denominator. X plus 1 cannot be 0, and therefore x cannot be equal to negative 1. What else? We have x plus 3 in the denominator, the main denominator. X plus 3 cannot be 0, and therefore x cannot be equal to minus 3. So these will be excluded. It's better to put them now. Now let's look at the expression here. This expression here, so we have a rational expression divided by another expression, which we can write it as rational x plus 3 over 1. Now dividing rational expressions is multiplying by the reciprocal of the second one, 1 over x plus 3. This is like what you do with when you divide fractions. So we divided this rational expression by this one. You take the first one in the numerator, you multiply by the reciprocal. And the good thing is everything is factored now. X plus 1 and x plus 3 greater than or equal to 0. This is 3 with the bracket. 3 with the bracket greater than or equal to 0. Now, so almost everything is done for the factoring. So we go and analyze each term. X plus 2 bigger than 0 when x is bigger than minus 2. x plus 1, this term here, x plus 1, it's bigger than 0, when x it's bigger than minus 1, and hang on, and then x plus 3, the factor x plus 3 is bigger than 0 when x bigger than minus 3. So we put our information on a table. Now let's put the zeros. That we have negative 3, it's the smallest, and then negative 1, negative 2, and then negative 1. The factors x plus 2 here. Now x plus 2 is positive when x is bigger than minus 2. Here is minus 2, bigger, that means you go to the left. So that's where x plus 2 is positive. Now let's put some vertical lines here. And of course the other side is going to be negative. Now when x equal minus 2, the numerator is 0. Now x plus 1 is positive when x is bigger than minus 1. Here is minus 1. Bigger, you go to the right. That's when it's positive. So all the other intervals gives you a negative sign. Now x plus 3, the last one, x plus 3, it's positive when x is bigger than minus 3. Here is minus 3. Bigger, you go to the right. So that's where x plus 3 is positive, and then positive. Here it is a negative. Now let's not forget negative infinity plus infinity. And then now we're interested in the sign of this, which we call y. So let's put it here, y. And then start. Now we go interval by interval from minus infinity to minus 3. What do we have? We have y equal x plus 2. X plus 2 is negative. So negative in the numerator. X plus 1 and x plus 3 are in the denominator, negative, negative. Negative and negative. Now the numerator is negative, the denominator is positive, and all this will give you minus. So my y is negative on the interval minus infinity to plus infinity. So now let's go to minus 3 to minus 2. Minus 3 to minus 2, x plus 2, which is the numerator, is negative here. The two terms in the denominator, one is negative, the other one is positive. When you multiply them, they give you minus, and the whole thing gives you plus. So plus for y. Here, from minus 2 to minus 1, the numerator, x plus 2, is positive. The two terms in the denominator, one is negative, the other one is positive. So it will be plus here, negative here, and that will give me negative. And then here everything is positive, that will give me plus. Now remember, we are looking for when y, this expression, is either positive or 0. So the intervals we are interested in is this one and this one, positive or 0. Not this one, not this one. Good, let's start working on the interval. So we have minus 3, minus 2. Do we accept minus 3? No, because it makes the denominator 0. Look, x plus 3. So minus 3 open. Minus 2, do we accept it? It makes the numerator 0, and equal to 0 is accepted. So we close. Union. This here is positive, so minus 1 2 plus infinity. Now plus infinity is always open. Now minus 1 makes the denominator 0. Look, x plus 1. If you put minus 1, it gives you 0. So it is not accepted, open. Now normally we should, let's go back to the table. Now normally we put the cross here because minus 1 makes our denominator, our term in denominator 0, and normally also we should put a cross here at minus 3. That will make it easier to exclude them when we write the intervals. So this is the we now present the solution on a number line, the graphical solution. So minus infinity, 2 plus infinity, negative 3, negative 2. Now the circle is closed at negative 2 and the values in between. Negative 1, open circle, and then 2 plus infinity. We now use the symbol of inequalities to present the same solution set. X strictly greater than negative 3, less than or equal to negative 2. Less than or equal because of the closed circle. Or x strictly greater than negative 1.